This tutorial is going to show you how to draw a Bohr model diagram which is concerned with placing electrons in the correct energy level. So for this first example, we have the isotope aluminum 27, and we need to remember what the 27 is telling us. The 27 refers to the mass number, which is the grand total of protons and neutrons. So we can use that to kind of tally up what's going on in the nucleus, and then we'll concern ourselves with what's going on with the electrons. Okay? So you would need to refer to a periodic table, and if you look up aluminum in the periodic table, you will see that the atomic number is 13. Okay? And that defines the number of protons in the nucleus. That also tells us how many electrons we're going to have in a neutral atom, because remember, the protons are positive, the electrons are negative, and in a neutral atom you'll have a perfect balance between positive and negative charges. So I'm going to keep in the back of my mind that my diagram should have 13 electrons in it. For neutrons, again, the 27 is the mass number, so I need a grand total of 27 particles in the nucleus. So that means my only option here is to have 14 neutrons, because 14 plus 13 is 27. And they're not really shown in this diagram. The nucleus is just kind of shown as a gray circle, a gray sphere, but we know that those protons are located there, and the neutrons as well. So we shift our focus to the electrons. I need to place those 13 electrons properly in the energy levels shown here by rings. So the first energy level is the lowest energy level. It can fit 2 electrons. The second energy level, the second ring, can hold 8 electrons, and then the third energy level can hold up to 18 electrons. So those are some rules that we need to remember. Now the other thing we need to consider is how to draw these. You see this done various ways, but I have a specific way that I want you to do it so that we're consistent, and it will help us when we get to chemical reactions and bonding to explain what's going on there with electrons. So I need to count out my 13 electrons and place them properly in this diagram. I would start by putting the first 2 electrons right here in the first energy level. I pair them, and it's full. Okay, that's as many electrons as you can fit in the first energy level. So my third electron is going to jump up to the second energy level. So there's number 3, 4, 5, and 6th electron here. And my suggestion is to draw those singly first. So we go right around the circle there. We've got our next 4 electrons. That gets us up to a total of 6. So we need to keep going to electron number 7. I pair it up. 8, 9, and 10. Okay. So the second time around the circle, I pair up those electrons. And again, that's going to make more sense when we learn more about chemical bonding and chemical reactions. So that's 10 of the 13 electrons placed. The next 3, I fill them in the same manner. So I go 1, 2, 3 more electrons. And that gets me to a total of 13 in the diagram. So I've got 2, 4, 6, 8, 10, 11, 12, 13 electrons. Okay. We'll see later on that what's really important with these diagrams are the electrons in the outermost energy level. It turns out that those end up being very important in the properties, the chemical properties of the element.